Right, what you write down here is how to get the vector equation of a plane, right? I'm going to re-explain it, but this diagram kind of that's not what I got. Like you can figure out faster. That's not how it looks.
Sorry. Yeah. So the mean times that's some argument down. You are and where yes. Yeah.
Right, I can take it off. Right, module 3, for those who don't know, or probably didn't start with it, module 3 is limits, differentiation, and integration, right? After this, that's how we start. Between now, you can do a full thing by the end, but it depends on after that, we start practice. So that you realize what but what I give it is not information. That's also five but it's the most 90 minutes down time. It's already yeah, also. All right, taking this off, right? Yeah. Adam, you finished? All right, nice. Adam finished, so I can take it off. Right, so what you saying? What do we just look at, right? In order for us to find the vector equation of plane, we need a few things. We need a point on the plane, let's call it point A, and we need something perpendicular to the plane, let's call it N. Right? So for us to get the vector equation, let's pick a random point on the plane. Let's call it R. Right? Remember, these are points, so to turn them into vectors, I could draw them back to the origin. Let's call O to A, lowercase a, O to R, O to R, lowercase r. That's okay? Now, we could find AR here. We can find the vector AR. AR is A to O plus O to R. A to O, sorry. A to O is minus A, and O to R is lowercase r. So we know that A and R is AR is minus A plus R. That makes sense? Sana? Yeah. Now, what did we say? What did we say about every vector on this plane and this end? They are what? Perpendicular, right? And we know that if perpendicular, we know that A dot B is what? 0. So if I multiply AR by N, what would I get? I'll get 0. So AR is what? AR is minus A plus R by N. So if I multiply this out, I'll get minus AN plus RN is equal to 0. If I move it across, If I move it across, I'll get Rn is equal to An. What you have there? Vector equation of a plane. Right? Remember, R could be anything. R could be any vector, xi plus yj plus zk. It could be anything, right? Okay. And if I plug that in here, I could also make it look like this, right? X, Y, Z by the perpendicular vector is A by N. Right? So what we have here and here is the vector equation of a plane. Right? If you were to multiply this out, you'll be able to get it Cartesian, right? But I want to give you an example. Right? So that's the thing that I have in your notes, right?
Yeah.
So this is what we're trying to obtain from that little proof there. Let's say I give you something like this. If let's say we have this. Let's say A is equal to 214. Right? What you say? How do we get the vector equation of the plane here, Nathan? Right? What you say? To get the vector equation of the plane, we know it's R by N is equal to A by N. R is that unknown vector. N is the perpendicular vector. A is the point on the plane. Right? So if we have something like this, R by 3 minus 4, 5. How do I multiply the vectors again? What is do again? Multiply the x, the y, and the z and add them up, right? 2 by 3 is 6 minus 4 plus 20. Right? I got 22. Okay? So the vector equation of the plane is R by 3 minus 4, 5 is equal to 22. Right? That's the vector equation. I could turn this into the Cartesian real simple, right? Because R is what? R is X, Y, or Z. Remember, R is at any point, right? And if I multiply it by 3 minus 4, 5, I will end up with 3x minus 4y plus 5z is 22. What do we call that? Cartesian, right? This is your Cartesian equation. And that's it. That's all you need to know. Okay, now? Let's just try up the questions before we move from this, right? I'm very bad. No, next one. Okay, shall we get into that? Right, so remember, once you get the vector, you just just bring in x, y, and z, and then you get the Cartesian, right? Right, question. Suppose you want to find where a plane and a line intersect. Which two would you solve simultaneously? Suppose I give you a line. Let's say I give you a line something like this. What would you solve simultaneously? You would solve the direction vectors, right? You would solve this and this. Right? You solve those two simultaneously, right? I'll show you an example of that. Right? Let's try this part table first now. Try part C there. I don't know what year it is, huh? Do part C, like 2 lines long, 3 lines long. Try part C.
What is it? Right.
What did I do? I do what? Part C alone, right? You're done? Right? They want vector, yeah? So don't reach all the way here. Just right here. Right, Nathan. What you got here? Why you still working on this, Nathan? Yeah. Nathan, what is the point on the plane? No. The vector equation of the plane passes through 130. Sorry, I put the wrong thing there. Right, so the general form is R by N is equal to H by N. So we know that N is what? N is what N here, Nathan? N is what? What's the perpendicular vector? 2, 4, 5, 9. Right? And then you have 2, 4, 5 multiplied by 1, 3, 0. So I got 2 and 12, 14. So I got that 14. So the answer is R 245 by 40. Hello, okay with that? Alessa? Everybody okay with that? Nathan, follow what to do now?
Yes.
You sure? Right, so you come and do this one here for me then. That's back to the equation of a line, don't worry about that. Last question, B and C. This is 2018, I think. B and C combines what we did last week as well. Oh yeah. So you have to find the vector equation and the plate, Isaiah, and then solve them. Oh yeah, that is. Good part.
Ja, wir haben Joke jetzt. Also be there. I would say as compared to no, no, no. Sure. Alright, you set up the same. It said for us, 10. I'll give you a point. I know, but I can put these around because you're fuck, you guys. We're going to go to I knew nothing. No, you can also be caught of. Yes. I'm a guy. Thank you. That's we could do this. It's so good.
You done? I'm sure. Right, let's see what we have here. He is what? Right, how we getting PQ is exactly? PQ is what? P to O plus O to Q. So that's minus 3 minus 1 minus 2. So we end up with what? Minus 2 minus 3, 2. I summarize it. We should get a lick some penance. Right? PQ is that, right? And part 2 is what? Part two is determine the Cartesian if it passes through Q and is perpendicular. So we know that the vector equation of a plane is this, right? And they want Cartesian, right? So I replace it R one time. X, Y, Z. Right? N is what? N is what, Connor? And in this question, the perpendicular vector is what?
Or
Minus 2 minus 3, 2. Right? A is what? A is what again? Which point on the line? I don't know. What is it? Right. What's the point on the plane? What's the point on the plane? The point on the plane is Q. So that's 1 minus 2, 4, and you multiply it by this. So I have minus 2x minus 3y plus 2z is equal to this value here, right? I got minus 2 plus 6 plus 8. Anybody got this for the equation? Yeah? Okay. You up to the next one already? You start the next one? Oh yeah. Okay, great. Oh yeah, try the last part faster. Right, find the vector equation quickly. Sorry, solve simultaneously. All right, yes. We have to solve it online. This was the answer to part 2, right? That's part 3 then. Right, this was part B, and this is part C. I'm going to do this now, right? So remember, solve and then plug it into C, right? Right? Convert the form quickly. Now go on rush the limit. So I think we just start the printer, let's take it over. Huh? I saw last week. Put it in a parametric form and solve simultaneously. Right? Let me put it in parametric form then, Nathan. Nathan, that's my here now. Put this in parametric form for me now. Minus one minus, right? Y is what? And Z is, right? And then L2 Keshav. What's L2? Minus 2 plus beta, nice. Y is what? 1 minus beta, very good. And Z is? Minus 4 plus beta, nice. So now we're just going to solve the X. Solve these two simultaneously. So we're going to equate, right? We're going to equate the X and equate the Y. So I got minus 1 minus 2 alpha is minus 2 plus beta. 1 plus alpha is equal to 1 minus beta. Solve them simultaneously. And what do you do with alpha and beta after? Substitute it where? NC. And if they equal, they intersect. Are they supposed to be equal? Yes, because the question said they intersect, right? Oh yeah. Solve it fast. And I rush into limit again. Right? We'll do it next. Want to rush to the next case. Right, so adding everything, I got what, 0 there? I got 0 minus alpha is minus 1. Anybody get that? Alpha is 1. Alpha is 1. Plug it in here, and you get 1 plus 1 is 1 minus beta. I got beta to be minus 1. Yeah?
Yeah.
You have 1 and minus 1, drop it in here. For L1, Z is minus 2 minus 3 by 1 minus 5. For L2, Z is minus 4 minus 1. So they equal. So they equal, therefore they intersect. And I think they actually point after it. They actually point. The Z value is minus 5. Plug in 1 here. I got minus 3. But look at this. Minus 3 to minus 5. No. No. What you got? Huh?
I don't know.
Check it back and see. Minus 3 to Yeah? All right, nice. Online. Agora, section. Online, palagara, Tanya, palagara. As we did last week. You write a vector equation of a line. You must have a point on the line. And now back to the power. And then all you have to do is bring all the x's together, bring all the y's together, bring all the z's together. And you get the parameter. Solve them. If they give you the same values here. Otherwise it's not. Alright, here we have a slight problem, right? They want us, Adam, to find the angle between two planes. How we got that? I find the angle between well, what you found of the angle between two vectors again? Cosine theta is equal to A dot B over mod A mod B, right? So all we have to do is figure out what A and B. What will be A and B? What we could then use the A and B. Look at this here. What can we use the A and B? We need a vector. So we're using the two vectors. So we're using the two perpendicular vectors, right? We're using the two direction vectors. Right, so use the two perpendicular vectors. A is 1 minus 2, 4, and use B as 2, 3, 1. And then find the angle. That's it. Okay. Ano yun? Ang galing yan. The angle? Up? Right, so we should have E dot B by now. A dot B is equal to 2 minus 6 plus 2. So you end up with 0. If the dot product is 0, what does that mean? Since the dot product is 0, theta is 90. And last thing that we have to be able to do right. Here we have a new problem. We have a line and we have a plane. And we want to find where they intersect. How we going to attempt to do that? How we going to take this and solve with this? Any ideas? Anybody, any ideas? Right, guide it down to solve to solve a line and a plane simultaneously. We do the following. Step one, we do the following. Step one, write the vector equation of the line. Write the vector equation of the line. In the parametric form. Write the vector equation of the line in the parametric form. Step two, substitute x, y, and z. Substitute x, y, and z from the parametric form of the line into the equation of the plane. Into the equation of the plane. Step three, solve for unknown variable. Step three, solve for unknown variable. So technically we're trying to solve for t, right? Right now? Put it in the parametric form, and then when you put it in the parametric form, substitute x, y, z, and then solve t. Right? Parametric form is where you have x in terms of t, y in terms of t, right? Get the parametric form. Right? You this one already have it for yet. What's x here? X is this, right? Y is this? Here's this. This one already organized for you. Already organized. What we gonna do now? Right? Substitute x, substitute y, substitute z. I got positive feedback. Somebody got one, correct?
No, didn't put answer.
So negative. Negative 40. Put it back in here, right? Still get it point. Right, remember the point of intersection, yeah? So after you figure out T, put it back in here and get it point. Okay? So when we substitute, we're going to get minus 2 plus T plus 3 by 3 minus T plus 2 by minus 2 plus T is 8. Right? So I have 2 minus T plus 9 minus 3T. And you add it up, I got minus 4. That's minus 3.
Says no.
Oh, where get that from? 1 plus T. Five and 2, right? So now they want the point of intersection, right? So to get the point of intersection, we have to plug in T here. Right, so I have 0.5I plus 0.5J. What I got that? 3.5K. Anybody get this? That's a point?
Yeah.
Nice. So we have time for one more. We didn't start it. Huh? All right. So the next thing that, sorry, so this brings us to the end of module 2. Right? Module 2 was vectors, geometry, coordinate geometry, and traits. Right? Next we have limits to do, then differentiation and integration. Content is not plenty, but it's plenty to practice. All right? Limits short, and then differential and integration not too long. Right? But we had to practice a lot in that particular module. I believe that's the model that coming out a little bit hard. All right, so we will stop there. Next week we focus on limits